Second example on the ionic equations. Okay, so we have sodium hydroxide, which is in aqueous, which is reacting with, this is hydrochloric acid, which is in aqueous solution, to produce sodium chloride in aqueous solution, and the water, which is a liquid substance. Now, step number 1, construct a balanced chemical equation. Is our equation balanced? Let's try and see. We have one sodium, one oxygen, two hydrogens, one chlorine, So the equation is already balanced. Point number 2, split soluble ionic compounds into ions. So we are going to split these which are in aqueous solution. So we have sodium, which is with hydroxide ions. So we just put a negative here because this is one positive, this is one negative. So plus, this one is also in aqueous, hydrogen, which is always a positive, and chloride ions, which are negative, to produce sodium chloride, which is in aqueous. So we split it as sodium ions plus chloride ions, and this one, which is water, it is in a liquid state, so we don't split it. So H2O as liquid. These are all in aqueous. Next, we cancel out the spectator ions. So we have sodium here, we also have sodium here. So we cancel this, we cancel out this. Do we have hydroxide ions? We have them here, we don't have them here. Hydrogen ions, we have them here, we don't have them here. Chloride ions, we have them here, we have them here. So we'll cancel out this and also this one. Then you go ahead and rewrite without the spectator ions. So we have hydroxide ions, which are reacting with hydrogen ions to produce water. As a liquid substance. So this is aqueous liquid substance. Okay, so this was the second example. Thank you for watching. Don't forget to hit the like button and subscribe to our channel. Let's dive into the third example. Calcium hydroxide, which is in aqueous, reacting with the sulfuric acid, which is in aqueous, to produce calcium sulfate, which is in aqueous, plus and water, which is a liquid. So step number 1, construct a balanced chemical equation. Is our equation balanced? We have one calcium here, we have one calcium there. We have how many oxygens? We have 1 times 2 here, which is 2, plus 4, which is 6. How many do we have here? We have 4 here, we have 1 here. So there is a problem with the oxygen here because here there are 6, here there are 5. Come to hydrogen. Hydrogen 1 times 2, which is 2, plus 4, or plus 2, which is 4. Then here we only have 2. So there is a problem with the hydrogen again. Sulfur, we have 1, we have 1. Okay, so the problem is just on what? A substance which has got oxygen and the hydrogen. And what substance is that? Water. So we need to make hydrogens this side to be 4. We must also have 6 oxygens, which are this side to be this side. Therefore, since we are beginning with the interest of hydrogen 4 here, then we'll deal with hydrogen, which is there. So what number can we put to make these 2 to be 4? Which is just a 2, yeah? So we put a 2 here. So it will be 4, automatically 4. So let's counter check. 1 calcium, 1 calcium. Oxygens, 1 times 2, 2 plus 4, 6. 4 plus 2 times 1, which is 6 also. Hydrogens, which is 1 times 2, 2 plus 2, 4. Then 2 times 2, which is 4. So our equation is balanced. We are done with the first point, which says construct a balanced chemical equation. Split soluble ionic compounds into ions. Okay, so aqueous compounds. We have calcium hydroxide here, which is calcium ions plus hydroxide ions plus sulfuric acid, so hydrogen ions plus sulfate ions to produce. This one is also in aqua, so we split it out. So calcium ions plus sulfate ions plus water. So we have got water there. Water. So which is just like that, as a liquid substance. Okay, so someone might ask you to say, where are these ions coming from? How does he know to say this is plus 2, this is minus 1, this is plus 1, this is minus whatever? Okay, so simple and straightforward. We'll talk about radicals very soon, where we find these as valences. Okay, so step number 3, cancel out the spectator ions. So we're going to cancel out the spectator ions. We have calcium ions here. Do we have calcium ions at the product? Yes, we have. So we cancel out this. We also cancel out this. Hydroxide ions, we have them here. Do we have them here? No. Hydrogen ions, they are here at the reactant side. Do we have them at the product side? No. Sulfate ions, do we have them at the product side? Yes. Okay, so this and this, they are cancelled. Last point, write without the spectator ions. So we just go ahead and write them without spectator ions. So we have this one plus this guy, which is hydrogen ions, to produce which one? Water. So H2O. H2O. So yeah, that is how it is. That is how it is. Thank you for watching. Don't forget to hit the like button and subscribe to our channel as we dive into the 4th example. Yeah. The 4th example. Silver nitrate reacting with sodium chloride to produce silver chloride and nitrogen or sodium nitrate. Okay, so now is the equation balanced? Because first step, balance the chemical equation. Balance the chemical equation. So we have 1 silver here, we have 1 silver there, we have nitrogens. How many are there? 1 here. So how many there? 1. Oxygens, we have 3 here, we have 3 there. Sodiums, 1, we have 1 there. Chlorine or chloride ions, 1, 1. Oh, so the equation is balanced because we can't see any problem there. Then we split the aqueous compounds. Aqueous compounds, substances which are in aqueous solution. So we have this one. So this one is silver positive plus nitrate ions, which is negative, plus sodium, which are positive, and the chloride ions, which are negative, to produce silver chloride, which is silver ions, which are positive, plus chloride ions, which are negative, plus this one. Oh, this one is in solid, so we don't need to split it because it is a solid substance. Solid substance. Therefore, we'll just write it the way it is. So this is silver chloride, which is as a solid. Then plus we split the one which is in aqueous solution. which is sodium ions, which are positive, plus nitrate ions, which are negative. Next, we cancel out the spectator ions. So we are going to cancel out the spectator ions. So which ones are spectator ions here? Those ions which are on both reactants and the products. In this case, let's counter check. We have silver ions here. Do we have them here? No. So we'll leave out this. Nitrate ions, we have them here. Do we have them at the product? Yes. So we get rid of this and this. Sodium ions, do we have them there? Yes. So we cancel out this, we cancel out this. Next, do we have chloride ions that side? No. Therefore, we'll go ahead and rewrite without the spectator ions. So, plus chloride ions to produce silver ions or silver chloride. Yeah, which is a solid. So this is an ionic equation for the reaction of silver nitrate and the sodium chloride to produce silver chloride and the sodium nitrate. Thank you for watching. Don't forget to hit the like button and subscribe to our channel. But before you leave, here is an exercise. That is your exercise. Write the ionic equation for the reaction below. I will not read the reaction. Submit via WhatsApp on +2 6 0967 93 50 25. Yes, for those who are in Zambia, you can just start with 0967 93 50 25. Thank you for watching. Don't forget to hit the like button and subscribe to our channel.